Hi there, this is your favorite math learning channel, and I have a functional equation problem that was suggested by a viewer, and the only thing I changed is these numbers. His numbers were much higher, but nothing changes actually. So let's see how we can solve it. Well, we are given basically two recurrence relations about from even to odd and odd to even, and we are given the first value. So let's examine first few values, and then we will see if we can find the general term. It's actually a not hard problem. So let's see. So I know what is f1. Well, if I put n is equal to 1 at the first equation, I get f1. If I put it at the second equation, I get f2. So let's do it. f2. So I'm putting n is equal to 1 here. So it's just 2f1, which is 2x. Okay, cool. So let's do f3. Well, to get f3, I need to put n is equal to 2 here. So if I put n is equal to 2 on the first equation, I'm going to get f2 minus 1. So it's 2x minus 1. If I do f4, this is going to be, so I'm putting n is equal to 2 here, 2 times this thing, 4x minus 2. And if I do it again, it's going to be 1 less. So you can see the pattern here. So when I'm going from left to right, I'm just subtracting 1. And when I'm going diagonals, like to the one lower row, I'm just multiplying it by 2. Okay? So therefore, I can just write first few more values, and let's do one more. For also, this should be f5. So f6 is going to be just twice of this thing, 8x minus 6. And f of 7 is going to be 8x minus 7. So let's see now if we can find general terms. Let's look at the odd terms. So I have f3, f5, f7. And first thing I can notice is that I have 2x, 4x, 8x. Well, obviously, I was just multiplying it by 2, so I just got powers of 2. And so I'm gonna try to write f of 2n minus 1. And for example, to get 3, I need to put n is equal to 2 here. And so when I put n is equal to 2, I got the first power of 2. When I put n is equal to 3 here, I got second power of 2. So I'm just getting 1 less than this n. So I'm gonna get 2 to the n minus 1 x, and I have just this x here, and minus, so I'm just subtracting something that is just 1 less than this power of 2, so I can say it's 2 to the n minus 1 minus 1. And now if I just factor this 2 to the n minus 1 here, it's gonna be x minus 1 plus 1. Okay, cool. Well, it's quite simple. And for the next one, now let's do f2n. Well, I know that from second equation, f2n is just twice of f2n minus 1. And I already found what is this one. So I'm just going to multiply this thing by 2. And I'm going to get 2n, 2 to the power of n, times x minus 1, plus 2. Okay, cool. So now let's go to the question. Well, I'm given that f of 31. So to get 31, I would need to, so now let's say this is my first equation and this is my second equation. Well, they're basically same, but now I already know what is the general term of it without a recurrence relation. To get f of 31, I just need to put 16 here, n is equal to 16. So I can just write the question here, f of 31 minus f of 18 is going to be equal to, so I'm putting n is equal to 16 here. So it's going to be 2 to the 15 times x minus 1 plus 1 minus, and to get 18, I need to put n is equal to 9 on this equation. So it's going to be 2 to the 9 x minus 1 plus 2. So now if I just get everything, I can take it into parentheses of 2 to the 9 times x minus 1, 2 to the 9 x minus 1 So this is gonna be 2 to the 6, and this is just 1. And from this part, I just have minus 1. And from the question, I know that this is equal to minus 1. So I can just cancel these. So therefore, I get to the result that 2 to the 9 times x minus 1 times 2 to the 6 minus 1 is equal to 0. Well, obviously this thing is not 0, and this thing cannot be 0. So therefore, x minus 1 has to be 0. And from here, I can just say x is equal to 1. So this is our answer. Also, a quick note, like I said in the beginning, I changed these numbers, so they were like much bigger numbers. And here, if the n value is not same, well, if you're getting different powers here, you will always get something that is not equal to 0 here. So, like, except for if you have like literally same numbers here, x would always be 1. So at his question, I think it was like 1972. Sorry, it should be odd. 71 minus f of 1952. This was equal to minus 1. And then we literally have the same thing. Just the powers are bigger, but it's exactly the same logic. And the answer is always x is equal to 1.